Hello and welcome to the Tillage Edge with me, Michael Hennessy. This is your regular update for all your tillage news and advice. As harvest wraps up for another year, our focus turns to the next crop and also to our soils. Not all farmers immediately think about soils and the actions that can be put in place to improve them from year to year. The first place to start is to measure how your soils are performing at present. Yes, yield is one indicator, but there are certainly many more. Then try to decide the best interventions, if any are needed, and how long these new interventions should be practiced for. Fortunately, Teagasc have completed some work in this area over the past few years, and Dr. Mark Ward joins us today to discuss his work on headlands and how farmers can modify their practice to improve this area. Mark, you're very welcome to the podcast. Mark, in your recently completed PhD, what was involved in it, and what encouraged you to get into this area in particular?
I guess, Michael, between my farming background and knowledge of the industry, I was very aware of the concept of headlands being areas of reduced crop performance, particularly from a crop yield perspective. And then no one is ever really able to put their finger on it and quantify for me exactly how much less they yielded, or indeed indicate a definite cause. So I quickly realized that there's a lack of understanding really that existed out there with respect to the impact of headlands and tillage fields that exist in our climate, where soils are more vulnerable to soil damage and from compaction. So headlands, I guess, Michael, after all, are very important field areas, particularly in an Irish context where our average field size is quite small relative to fields in other cereal producing regions of Europe. So therefore, proportionally, the headlands occupy quite a considerable percentage of our fields. And then in addition to this, there's been an increase in the size and weight of farm machinery in recent years, with headlands being the field areas where all these large machines turn. While, as Dermot Forrestal has stressed a good bit over the last years, while the tire sizes may have increased with machinery over the years, it can be debated whether they've really increased enough to consider the extra load. And then in addition to that, Michael, many fields now at this point in 2021 are in long-term tillage really from the 1970s. So some of those fields would not have really received any inputs of organic manures, particularly in recent years as the scale of farming operations has increased. And then also grass is no longer really a component in the rotation for many tillage producers. So I guess that this interesting subject and an awareness of this problem led me to pursue a PhD to invest the impact of headlands and soil structure and crop performance. And that's where I am today.
As you say, Mark, the headland is a fairly major component of a field, especially a small field, and that delivers, if you like, part of the average yield. And if that's not performing well, your average yield isn't going to be performing terribly well. And just in your research, Mark, did you do most of this in oak park and controlled situations, or were you out in commercial farms? And if you were out, did you try and mix it up a little bit in terms of plough-based systems or the maybe non-plough-based systems?
Yeah, as you correctly said there, my PhD involved a survey of many different sites. In fact, there was 40 sites in my research, and that was over 2 years. All those sites were mainly conventional plough-based systems, and only fields cropped for at least 3 years prior to that were selected. So you mentioned there about alternative establishment systems, but in terms of, I guess, resources, budget, and time, and then also the stats at the end, we decided just to at least consider just keep it to just plough-based systems for this study. So essentially, we avoided fields with alternative systems, and then also with root crops or vegetables. The 40 crops in the survey consisted of winter barley, winter wheat, and spring barley. And they were grown on mainly loam and sandy loam soils, which are representative of the typical Irish tillage soils. These sites were distributed throughout the main cereal growing region of Ireland. So essentially, Michael, if you were to draw a line between Dundalk in the northeast to Cork, all the sites in the survey were scattered to the right-hand side of this line. And then, of course, look, I'm hugely grateful to all the farmers who facilitated my research. And without them, this body of knowledge or work would not have been possible.
So I presume on a plough-based type of system, because it's a plough-based system to a degree, it's almost self-correcting in the sense that it is a plough-based system. We might come back to this later on in terms of the differentials maybe you might expect to see maybe between plough and maybe some of the non-plough-based systems. But before we get that far, I might just go back a little bit, and you obviously did a lot of assessments, I presume, on the ground in terms of looking to see how those soils are performing. What sort of assessment tools did you use? And are those kind of tools or methodologies, if you like, are they usable by a farmer on the ground with maybe a small bit of training or that?
Yeah, that's correct. Throughout the study, would have used a range of visual and quantitative soil assessment methods to quantify, let's say, the impact of that machinery traffic has on the soil structure on the headlands. The chosen methods we used were VES and double spade as the two visual methods, and then bulk density and cone penetrometer readings were taken as the quantitative methods. VES, I'm not sure how familiar you are with the visual methods, Michael, but VES is a visual method. It was originally developed by the SRUC in Scotland. It's a spade method, so you don't actually need to dig a soil pit, but it makes life an awful lot easier if you do excavate a soil pit, so that you have a nice pit face. But anyway, this method, VES, assesses the plough layer, or the top 20 centimeters of the soil profile. And then in the lower layer, we used the double spade method. So that's a more recent method. It was developed by Chagas in the last 5 years, and assesses to 40 centimeters soil depth. Both of these methods are detailed in the Chagas soil structure ABC guide, and in this booklet there's a simple step-by-step picture instructions that farmers can use to implement VES and double spade on their own farms. All they need is simply a spade and a trowel, or even their penknife, so no specialist equipment is required. And there's also a smartphone application available to assist users in conducting VES as well. However, look, one piece of advice I will make is that while we are discussing headlands in this podcast today and how to assess them, I would recommend farmers or growers to first assess good areas in their fields before they go to the headland. This will help calibrate their eyes into the methods. And then when they go back to the headlands, they'll quickly be able to identify how much poorer the soil structure is in those particular areas, and it'll give them an indication of what they really need to work on.
So even for myself, Mark, I've had a go at the VES, and it is possible to do it. But even when I was doing it, having a small little bit of instruction at the time, at the very start of it, certainly helped. So I suppose for farmers maybe are part of discussion groups, they should maybe try and get the discussion group maybe to have a look at that as a particular training kind of thing for themselves, so they can go back home and do it for themselves. So coming back just again to the headlands in terms of, and at the very start, your motivation, I suppose, was to look at and see whether they were lower performing parts of the field. Did you find that in your research?
That's a good question, Michael, and that's probably what everybody here today is looking to find out. As expected, like the research proved that with increasing levels of machinery traffic on various parts of the headland, there was a resulting negative effect on soil structural quality. However, unexpectedly, the grain yields only follow these trends to a limited extent. So although crop performance varied between sites, the main field area which let's say that's the infield area away from the headlands, that was always the highest yielding area, like in all 40 sites in the survey. And then we anticipated at the machine turning area, let's say that's where you lift your plow and where you turn the drill on the headlands. We expected this to be lowest yielding area, but in fact was actually the outer six meters, so the 6 meters from the hedgerow in or from the crop edge in. In this area, we documented yield penalties of up to 11% for winter barley, 24% for spring barley, and 30% for winter wheat. So when we put this crop performance impact with soil structure, in fact, we mentioned a minute ago, like it really highlights the need for growers to assess their soil structural condition before longer term damage is caused. And then it's also worth noting that not all headland effects can be explained by the soil structural impact, and consequently that led us to investigate another possible factor in the final year of my PhD research.
So what you're kind of saying there is that machines are big and heavy and they turn a lot, but it doesn't necessarily mean that you're going to end up with less yield. The soils might be slightly of less quality, I suppose, underneath that particular area, but yields mightn't be. You mentioned some of the other factors. What are the other factors that you did find?
Yeah, that's correct. And the way you summed it together there nicely, so you did. And at the end of the day, like it is a cumulative effect. So like these fields do have histories of tillage, so they're out of like lay or grass rotation. Grass rotation is a long way back now, and one of the factors that we evaluated, or the additional factors, was fertilizer spreading, and like that, at the end of the day, that's hugely important. So it is, Michael. If you put that into perspective, if you have a 4 hectare field and you're operating on a 24 meter tramline system, the headland bout accounts for almost 50% of that field area. So it's vitally important that you spread your fertilizer on your headlands correctly. And in the final year of my PhD, I conducted a survey of fertilizer spreading with the same growers that I previously mentioned. And we found that fertilizer spreading on headlands tended to be uneven, with average application rates varying from 70% of the field rate at the field edge, now that is, to 120%, so 20% extra at the machine turning or the transition area between the border spreading and the infield bouts up and down the field. However, variability was much greater than this, with individual zones receiving anywhere from 1%, so very low application rates, to 150% the target rate. So they are the two main sources of unevenness on farms, and it's important that that's addressed.
So Mark, even from that sounds absolutely enormous. I mean, even from the point of view of you can imagine, you often would see it the lodging in those ins and outs, if you like, from one side of it, and maybe the other side of it then in terms of that over application, a hedge that is getting way too much fertilizer and spurring on weeds in the middle of that. So for all of that and for all of your knowledge as you've come through, how much of that can be influenced by the farmer? I mean, obviously some farmers are doing it reasonably well, but is it easy for farmers to get on top of it?
That's a good question. Well, when spreading on headlands, all modern spreaders have a border control mechanism for the headland run. Essentially, instead of a wide overlap pattern on one side of the spreader, this mechanism modifies the spread pattern for a sharper drop off to avoid, as you mentioned there, the higher application rates going into the hedgerows or outside the intended field area. Different manufacturers use different mechanisms to achieve this. On some spreaders, different discs or vanes are used, while others engage a deflector plate or vary the fertilizer drop point onto the disc. However, each of these mechanisms I just mentioned there, like they're all adjustable, so there's a need for them to be adjusted and calibrated to suit the particular system on the farm on that day. And there are tray tests that can be done to specifically test the headland pattern also. And then also there's both tray tests, as I said there, and there's also some other manufacturers now also have mats that you can use with an app on your phone. Another point to consider is where to turn on the fertilizer spreader when spreading the main field area. Many spreaders project fertilizer considerable distances, and not only across the field, but also behind them. And some manufacturers recommend that you must be up to 1.5 times the bout width from the edge before turning on, which may seem like a considerable distance, Michael, but will result in overspreading on a large crop if it's not followed. And GPS guidance is one method that operators can use to try and perfect this.
Sure, I was actually going to come to that because in fairness, I think TAMS and the TAMS grants out there have been probably utilized probably more so in the area of buying fertilizer spreaders maybe than any other machine out there for the most part. So there's probably a lot of good machinery out there. So in terms of the survey that you were doing, I presume you would have seen a good bit of this new machinery out there, but was the error more based around the operator error, if you like, rather than a machine not capable of doing what they wanted it to do?
Well, as already mentioned, many different spreader manufacturers use different border control mechanisms, but they may also have contrasting basic spreading mechanisms. So, such as, let's say, the more traditional wagtail or inward or outward spinning disc. Some also rely on overlap patterns, whereas others don't. When you mentioned about operator error, like all of those methods are extremely accurate and capable of applying fertilizer uniformly, but calibration is essential. I can't stress that enough. Many manufacturers have excellent online resources and smartphone app resources to guide operators in setting their spreaders. But aside from that, it's important that good quality fertilizer that can be projected at the desired bout widths is also used. So fertilizer particle size distribution will have a large impact on spread uniformity, where larger granules can be thrown further than smaller granules, and the more variability in the compound generally increases the risk of uneven spreading. So you have to make sure to aim for good quality fertilizer, 80% of the granules in the 2 to 4 mil range. On the day, other variables that need to be considered are forward speed of the tractor, wind speed, height of the spreader above the canopy, and also to ensure that the machine is level on the link arms when viewed from the rear if you're standing on the tramline looking at the tractor. In my research, I actually did in the final year, we also did a focus study with 6 of the growers where we implemented double headlands ourselves and spread fertilizer using a pneumatic boom shredder. And then, believe it or not, much of the previously documented headland yield variability was removed, which was quite interesting to say the least. And then that indicates that, like, really that there is a need on farms to ensure border spreading is effective.
So as we mentioned, there was a lot of there is more and more, I suppose, precision technology being used out there, certainly with the likes of fertilizer spreaders. But there's also, I suppose, precision technology in terms of the steering and tractors as well. When it comes back to the headland and machinery on that, whether it's fertilizer or maybe the machine turning, is there a role there for that precision technology, you think, in terms of minimizing soil compaction on headlands?
Well, absolutely. While we're still on the subject of fertilizer, GPS guidance and section control will allow for more accurate merging of headland and infield patterns, particularly in our small, irregularly shaped fields in Ireland. But don't forget the position for turning on and off must be set correctly in the screen, so the screen is only as good as how you set it to. Then from a soil perspective, use of larger tires with reduced ground pressures will help with soil stress. And then perhaps in the future, we don't know what's coming in the future, but the use of fully autonomous vehicles may even become an option. So that would be interesting space to follow.
So so we talked a lot about the headlands, and we've also mentioned soil compaction as we're going. So how often should a farmer look at the soil structure on headlands to see whether the quality of the soil within those headlands is good?
Michael, only the farmer that's working the field really knows that question. They know the history of that field. Did they establish the crops in poor conditions that the previous autumn or that spring? How deep are the tram lines up and down the fields, and more specifically on the headlands? So without even getting out of the tractor to have a look, the farmer will already have a good idea if they're in a bad condition or not. And now in the current period we find ourselves in now, post-harvest is an excellent time for growers to get out of the tractor, go across the field with a spade and assess like the soil structure in their fields, and more specifically on headlands. So look, if we're in a good period of weather now, so this is an excellent opportunity, and it's something that really needs to be considered every time like you get good weather like this before you consider any remedial action. But it is a good exercise to do probably on an annual basis. First of all, growers should identify the area that is compacted by digging a soil pit. That's what I'd recommend. And then using a trowel or penknife, locate the zone, let's say on the pit face of greater resistance. And then if they feel that they're competent enough, they can use some of those visual methods that I mentioned earlier. But before considering subsoiling, it's very important to ensure that the soil is dry enough to make sure it cracks the soil rather than smearing it when the machine passes through the soil. And then when you do that, then try to sow winter crops soon after in dry conditions. If it rains, the cracks will variably get filled up with water, and then the soil is more prone then to recompaction. And then alternatively, if you're in a spring cropping system, crops should be sown in the spring once those cracks have dried out, so that you're not going to pose the risk of recompacting the soil. And in fact, creating that compaction layer deeper down, so you're actually ending up with a worse problem in long term.
Okay, so Mark, I'm going to ask you a final question. It might be a little bit unfair, but I'm going to ask it anyway to see where we go with it. So say a farmer has identified a particular headland, and I'm talking about a relatively big field now rather than a small field, because as you mentioned, the 4-hectare field, 50% of it is made up of headlands anyway, so something a bit bigger. He has identified a little bit of compaction on the headland, and it's maybe a little bit damp. Is a reasonable method to go about that is just to have this double headland? So in other words, he's bringing the headland out one whole tram line, if you like, and that's where the farmer is going to do all the turning, and leave the inside part then to, I suppose, mind itself, if you like, and maybe it might repair itself over time. Would that be any sort of a sensible thing where a farmer can't do any, I suppose, mechanical intervention?
That's a good question, but often in many cases today that option loses out in favor of machine efficiency and productivity and less efficiency and less tram lines in the field. So that option isn't always there for growers, but they are an option, however, for fields that have been identified with compaction issues, if you can afford to set them aside or risk losing machine efficiency for a couple of seasons. And then that'll give the soils in those original headlands time to restabilize after you put the subsoiler through, that you're not actually risking recompacting it. But they are, at the end of the day, they are definitely only really a short-term option, because not every really field facilitates the permanent movement of headlands, and nobody really wants double headlands on a field long term. And then, like, really, if growers essentially keep an eye on soil moisture conditions before fieldwork, particularly cultivations, use low ground pressure tires, and then correctly set their fertiliser spreaders, their headlands really will thank them at the end of the day, so they will.
Okay, Mark, I really appreciate your time. There's lots of good information there. Hopefully everyone's got a little bit out of that and is a little bit more informed. And as you say yourself, get down off the tractor cab and get that spade out and get digging. Mark, thanks very much for your time.
Thank you very much, Michael.
So that's it for the Tillage Edge, and my thanks to Mark for joining me today. The Teagasc Crops Forum is coming up in a couple of weeks on September the 9th and September the 16th. Both are webinars starting at 11:30 a.m. The first webinar focuses on variety selection and the threat of septoria to wheat, and we will also cover grain market prospects in the short and medium term. The second webinar hones in on carbon capture on tillage farm and also the problem of nitrogen losses from tillage farms. You can register for both events at teagasc.ie/events. So finally, don't forget, if you like this podcast, then recommend it to a friend or colleague. And as always, review and subscribe on Apple Podcasts or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy. Thanks for listening. I'll be back next week with more tillage news and advice.